Okay, let's talk about the domain of a function. Here we are referring to the possible input values. So it's what you can put in for x. Be on the lookout for your even roots. So this is usually a square root. We don't write the 2 there, but there really is a 2 on the outside. Something like a 4th root or a 6th root. In this situation, remember we cannot square root a negative number. And also recall that we can never divide by 0. So in rational functions, make sure that you are aware of values for x that will cause the denominator to be 0. Then we move on to the range of a function. This is the output. These are the possible y values. Let's look at a few examples. So in our first example here, we have y equals 1 over the square root of x minus 4. If we were to put this into the calculator and sketch it, it looks something like what I have drawn here. It appears to begin at 4, and then it goes to the right and levels off on the x-axis. We actually have a couple of asymptotes here. We have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 4. So our domain here is going to have to begin with 4, but we're not going to include the 4 because we know that if we plug 4 into this function, yes, we can square root 0, however it's in the denominator, and we know that we cannot divide by 0. So it begins at 4, but not including that 4, and it will stretch all the way to infinity. So anything less than 4, including 4, would not work in this function. And you can see in the graph it doesn't stretch that far over. Now with our range, make sure you go from least to greatest. Whether it's domain or range, we always want to express this from least to greatest. So the smallest would be 0, but it's not going to include 0. Okay, we're never going to have a y value of 0. Notice our numerator is 1, so the only way to have a y value of 0 would be for the numerator to be 0. So it's going to start at 0, and because there really is a vertical asymptote at 4, it would stretch up forever. It doesn't appear that way based on our graph, but if you were to plug in, and I suggest you do this with your calculator, plug in something like 4.000001 for x. If you do that, you're going to get a very big number out for y. Okay, so we have our domain and range, which you can see has some restrictions. Let's look at another example. How about we look at y equals 3 times the sine of x. Now our domain here, the possible x values, there are no restrictions. We could always plug in any number into the sine function, and it'll give us a result for y. So when this is the case, we say all real numbers, or we can express that by writing negative infinity to infinity. Now for our range, our possible y values, we have to keep in mind that there is a 3 in front, which is stretching this vertically. So usually with our sine function, it goes up to 1 and down to negative 1. Well, because of that 3 in front, it's going to stretch it. So our range going to drop all the way down to negative 3, and including that negative 3, and then all the way up to positive 3. We're going to use square brackets here since we are able to reach those values for y. One more quick one here. Suppose we have y equals 5 minus x squared, which I sketched below. So this is a parabola that opens downward, and it starts up here at 5. So our domain, our possible x values, it's unrestricted. You could always plug in a number and you're going to get something out for y. However, our range here, notice the highest value it reaches is 5. It goes all the way down, so this would be negative infinity up to 5 and including that 5.